Okay. Now we will try to do another test that is called impact test. So in the crushing test, that load was applied gradually, but in the impact test, load is applied as impact. Impact means sudden application of the load. Okay. So impact test is also very important, and impact test is conducted to find out the impact resistance of the aggregate or toughness of the aggregate to break down under the application of the impact loading. So we'll directly go to the simulation portion. So basically this is your impact testing machine. Okay, this is your impact testing machine, and this is the rammer, and this is your mold. Similarly, in this mold also you have to take the aggregate in a three layer tamping with 25 number of flows. After placing the aggregate over there, you have to take the initial weight, and after that you have to place the mold over there, and you have to apply impact loading using this hammer. Okay, using this hammer you have to apply impact loading, and you have to keep hammering the aggregate with the total number of blows is 15. Okay, so let us start this test. Then place your aggregate. Now sieve size will be similar as of the crushing value test. So first would be 12, then 10, then your pen. Okay. So aggregate will be passing through 12.5 mm sieve and retained on 10 mm ISC. Okay. Then you have to take the weight of the empty mold. This is similar as of your previous experiment. Then put your aggregate in the mold in a three-layer system. So first layer, sorry, that would be four-layer system. In some cases, you can also take three-layer system. Then tamp this. Another layer, then tamping, then another layer. Okay, so this stamping is done for a better compaction and remove any additional air voids. Take the weight, that is your W2. Then place this over there. This is your screw, it will be attached over there. And now you have to pull this up. Okay, and this sound will appear. So total 15 number of blows would be there. So after completing this, you have to clamp this. Then again, you have to sieve this through 2.36 mm IS sieve. So original weight of the aggregate was 350 gram, and aggregate passes through 2.36 mm sieve is 89 gram. So your aggregate impact test would be W3 minus W2 minus W1 into 100. That is like your previous crushing failure test. So you get the result 226 minus 1911.5. Okay, so your aggregate impact value would be 17.30%. Now, if you go for the theory of the test, so if your aggregate impact value is lesser than 20%, that is exceptionally strong. If it is 10 to 20%, it is strong. If it is 20 to 30%, it is satisfactory for road surfacing. And if it is more than 35%, in that case, it is weak for your road construction. So basically, that is the classification of the aggregate based on your impact values. Okay, in that case, let us start another test. Okay, this is the website where you get to know about all these tests. Okay, that is a virtual lab where you can get all these tests. Now let us start another test, that is Los Angeles abrasion test. So this Los Angeles abrasion test is conducted to estimate the hardness properties of the aggregate. Okay, so your crushing test was for the strength of the aggregate, impact test is for the toughness of the aggregate, and Los Angeles abrasion test is for the hardness characteristic of the aggregate. So there are different grading of the aggregate. So basically, in the Los Angeles abrasion test, what happened? There are different type of grading for the aggregate. and based on that grading you have to take some abrasive charges. So basically in the Los Angeles abrasion test, what happens, one cylindrical drum would be there, and in the cylindrical drum you will place some aggregate with sieve analysis, that sieve is also fixed based on the different regions and different categories. I will discuss this later on. So after placing the aggregate in that mold, then you have to place some cast iron balls in that cylindrical mold, okay, so, or cylindrical drum. So basically these cast iron balls are termed as abrasive chargers. So based on the categorizations of the aggregate, based on the sieve analysis, that number of the steel balls will also vary depending on the sieving of the aggregate. So let us directly go to the simulation portion of the test. So basically, this is your cylindrical drum where you will place your aggregate, and these are the abrasive chargers. Okay, these are the abrasive chargers. So basically, they are cast iron balls. So this is the gradation of the different aggregates. So for this, we will try gradation or grading B. Okay, we'll try grading B. So for this, we have to take sieve of 20, 12.5 and 10. And our number of abrasive charges would be 12, and their weight would be 4584 plus minus 25 grams. So first 10, then 12.5, then 20 ISC, then place your aggregate over there, close the lid. You have to go for the fix this, clamp this, and your sieving procedure is conducted. Unclamp this, like 5000 gram, that is the weight of the sample which we need to take. Okay, so that should be your 5000 gram. So that aggregate is passes through 10 retained on 12.5, and passes through 12.5 retained on 20. So you are taking the aggregate which are retained on 12.5 and which are retained on 20 IC. So that are the aggregates you have to take for your uh, uh, abrasion test. So you have to unclamp this, it will be open. Then your sample grade is B and abrasive charges is 12. Place this over there. These are the abrasive charges. So these are the cast iron balls, and you have to take a total number of 12 number of cast iron balls that would be placed over there. Then again you have to close the lid, and all the screws should be fixed very carefully. Okay, and number of revolution would be 500. Okay, so here number of revolution would be marked. You will start the machine, then this machine will start revolving. Okay, and you have to count the number of total number of revolutions. So it will generally take 1 to 2 hours time to complete all these revolutions. And during this test procedure, this test assembly produces a lots of noises. after the 500 revolution, the machine will stop. Okay, and in the below there would be one container where you will collect all this material along with that abrasive chargers. Then you have to sieve this through 1.7 mm IS sieve. Place this over the your vibrating machine and on this. Take the weight. Here one thing, you have to take the weight of the aggregate which retained on 1.7 mm sieve. Okay, so in previous two instances you have to take the weight which passes through IS 2.36 mm sieve, but here you have to take the weight of portion which have retained on IS 1.7670 mm sieve. Grade of the sample used, we have grade B. Original weight of the aggregate is 5000 gram. Weight of the aggregate written on 1.70 mm sieve is like 2499 gram. So your aggregate abrasion value would be W1, that is original weight of the aggregate, minus weight of the aggregate retained on 1.70 mm sieve divided by total weight. So basically, whenever you are deducting W2 from W1, you are getting the weight of the aggregate which passes through 1.70 mm. So basically, in this test, you are not directly taking the weight of the aggregate which passes through 1.70 mm because some of the dust particle will be attached with that cylindrical mold. Okay, so and some of the dust particles will be removed whenever you open the lid of the uh, of your cylindrical drum after the completion of the test. Therefore, you will not get the accurate result. For this reason, you have to back calculate the weight of the material which passes through 1.70 mmc. So, how you can do this? Just you have to take the weight of the retained material which retained on IS 1.70 mmc and deduct this value from the total weight of the aggregate, and you will get the total weight of the aggregate which passes through 1.70 mmc, and after that you can find out what is your aggregate abrasion value. So this is your result of aggregate abrasion value 50.02 percentage. So for the type of work for your wiring surfaces, that abrasive value should be lesser than 30%, and for non-wiring surfaces it should be lesser than equal to 50%. So whatever aggregate you have tested, that aggregate is unsuitable for your road construction. How you got 100.08? Your W1 is 5000. Your W1 is 5000 gram. Your W2 is 2499 gram. So 5000 minus 2499, it would be 2501. So your ultimate, it would be 2501 divided by 5000.
I calculated it wrong.
Okay, 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 Puri. You understood the test experiment, Puri?
Yes, sir.
Okay, okay. Okay, you can leave the meeting.